Welcome everybody to the Tulsa.NET user group. Tonight, Sarah Dutkiewicz talking on Azure Cosmos DB for Postgres for .NET developers. Sarah, I have not had you speak here before, and I am so excited to have you speak here. This is this exciting topic, and I know we've got a conference coming up. I'm hoping to see you there in Seattle, hopefully soon. Well, hopefully we'll see. I don't know, but anyway, take it over and tell us about Cosmos and Postgres.
Awesome. Thank you for having me. As Sean said, I am Sarah Dutkiewicz, also known as Sadukie. Before I get too carried away, can you all see my screen with the Azure Cosmos DB for Postgres? Okay.
Yes.
And do you see the UR screen sharing notice from Zoom? Okay.
No, you're good.
It's hovering, and so that's why I want to make sure it's not there. Awesome. So I am here to talk to you about Azure Cosmos DB for Postgres, and specifically for .NET devs, which means we're going to be looking at code, and we're going to be looking at how do we talk to Postgres from .NET, and how do we talk to Azure Cosmos DB for Postgres? By the way, hint, it's going to be using Postgres tools. So yeah, we'll talk about it. And it's relational data at any scale. Now, the demo I have tonight to stay within our time frame is just getting started with .NET and Postgres and calling Azure Cosmos DB. We're not going to get into the whole scaling part other than to talk about how Azure Cosmos DB for Postgres does it. So just be aware that I'm very well aware of time. I didn't want to put the whole thing in, but as much as I could get here. Okay. So we're going to talk about what is Azure Cosmos DB for Postgres. We'll look at setting up your resources in Azure. We'll look at some .NET resources and then demo. Now my demo, we're going to look at a bunch of different tools. So we'll look at Visual Studio. We will look at something called PG Admin. In Visual Studio, we're going to be looking at a clean architecture app, and then we're going to also look at a console app. I'm going to show you a gotcha, a nice pain point that Postgres brings to us, how we can handle it one of a couple ways. So rest assured, if you see something you're like, oh no, this is not going to end well, it will end well. But I want to take you through these pains too, because if you're getting started and you're like, why isn't this working? What's going on? Postgres has its own quirks. Then we'll go into some resources and Q&A. As you have questions, please chime in. I know Sean said he would watch the chat. Just feel free to interrupt. I would prefer we have the questions when they come up with the related content, rather than going all the way to the end and then you go, you know that thing on slide 2? You're like, no, what thing on slide 2? So please stop me along the way. Before I get too carried away with this, maybe a reaction, show of hands. Something, how many of you have used Azure Cosmos DB? Awesome. And then how many of you have used Postgres? Okay. So for those of you who are already familiar with Azure Cosmos DB, this is not your regular Azure Cosmos DB. So I will clarify what that means here in a bit, because I've been working with Azure Cosmos DB for a few years now. In the NoSQL, you may have seen me talk about the Gremlin API, the Apache Gremlin graph database stuff. But Postgres, this is relational data. So when I first heard about this, when I came out with it, was at Ignite in October, I was just like, wait, what is going on here? My world is about to fall apart. Azure Cosmos DB has always been in my mind the Microsoft flagship for NoSQL. NoSQL. And so I'm just like, okay, NoSQL column store, graph database, key value pair, but what's this relational data? Are you really sure about doing this? This my poor brain can't handle relational when it's all been NoSQL. Relational, that's my other stuff. But no. Azure Cosmos DB for Postgres brings in the relational data, and it's relational data at any scale. So Cosmos DB loves Postgres. All right, so how do you say it? You hear me say Postgres. You may say Postgre, PostgreSQL, PostgreSQL, however you choose to say it. For ease of saying it, I'm just probably going to call it Postgres. You might hear me slip and say PostgreSQL, but for the most part, I just go with Postgres. There is a tweet. So Claire Giordano does a lot with the Citus team, which we'll talk about what Citus is here in a minute. But she has a tweet where she talks about the name CitusCon, an event for Postgres, which I'll talk about at the end. It's an event coming up, and people are like, how do you say this? So it was hilarious when I watched it. I was like, yeah. And she likes her M dashes. Okay. So what is Postgres? If you're not familiar with Postgres, if you're coming at the relational world from something like a SQL Server or MySQL, Postgres, think of it, Postgres is in the relational world. It's been around for quite a long time, as you can see with the slide. The timeline is from 1986. It started out as a research project at UC Berkeley. 88, you'll see it's at a ACM SIGMOD, so we're talking at academic conference, the Association for Computing Machinery. In 94, they had a SQL interpreter added, and they renamed their project from Postgres to Postgres 95. If there's anything we know being Microsoft people, do the years in our versions really help? No, it just shows even more how dated the technology is. We don't want to do that. But they went with Postgres 95. They introduced a tool called PSQL for their interactive queries. They added a front end. In 1996, that's when they're like, yeah, that Postgres 95 wasn't a good idea. Let's just call it PostgreSQL. A lot of stuff has happened between now and then, but I only have so much room on the slide. So let's fast forward to 2022 when Microsoft had their big event in October and Azure Cosmos DB announced their new API, Azure Cosmos DB for PostgreSQL. It's a lot to say. All of the APIs are now named really, really long names. But Postgres is a relational database. So now what is Azure Cosmos DB for Postgres? So Azure Cosmos DB for Postgres, this is the artist that's formerly known as Azure Database for PostgreSQL Hyperscale. That was its name way back before October. So there's Azure Database for Postgres, single server and flexible servers. Single server is on its way to getting retired. Flexible servers, you just want to stay with going Postgres and you're fine with having it being a managed service in the cloud, that's fine. But if you want a managed service with the ability to have distributed data, this is where Azure Cosmos DB for PostgreSQL comes into play. So you can go from a non-distributed relational database to a distributed with very minimal friction. What that means is that you could, and my demo, I'm only going to start on one, and I'll explain why, but I can go up to as many worker nodes as I want. I'll talk about what those are. We'll tell you how I can avoid restarting when I do my scaling and kind of talk about it from there. So I'm not going to demo the scale out and the sharding and the remodeling of your database because that takes a little bit more explanation, but we're just going to go with what we've got here and then talk about how that all will change. Sharding data. So what this allows us to do is it allows us to group our data by a certain column, split it up, allows us to do parallel processing of queries, so faster queries. This can also be a pain depending on how your queries are structured versus how you organize your data. Again, that's a whole separate talk. But with Azure Cosmos DB for Postgres, this is the managed Postgres service, and it's powered by an open source Postgres extension called Citus. That is Citus, spelled C-I-T-U-S. There is no R, there's no lemons, no oranges. This is not citrus, it is Citus. I don't want to know how many times the browsers in the search engines are like, did you mean citrus? No, I really didn't. All right, so what is Citus? Citus is an open source Postgres extension. It's been around for a while now, but it allows you to distribute your data across multiple nodes. If you have a Postgres server of your own, you can use this Citus extension, but Azure Cosmos DB for PostgreSQL is the hosted option for that. So Microsoft is hosting it, Azure's hosting it. They handle the physical machines, but you still have some say in the configuration with the scaling and such. So why Citus? Well, let's say you're working on a single Postgres node and you start to realize that you're growing. You're growing either too much data, or maybe you need more processing power, more storage, things like that. Well, how do you grow? This is where Citus comes into play, because Citus will allow you to do that. You can stay in the Postgres realm. and take advantage of using all the extensions that are available for Postgres as well. This holds true for Azure Cosmos DB for Postgres because there are extensions that it supports just fine. There are some gotchas to some of the extensions based on if you need administrative access because it's hosted in the cloud. Microsoft has taken away some of that, some of the administrivia essentially. But even with Azure Cosmos DB for PostgreSQL, you can use things like hyperlog and PostGIS. No, there's a lot of different features for Azure Cosmos DB that you're going to see in Azure Cosmos DB for Postgres. So the high availability, your read replicas, your backups, seeing your different SLAs, seeing just how it works, that generalization applies for Azure Cosmos DB. But Azure Cosmos DB for Postgres itself, you have to think about it as this way. Each of the machines that are hosting your Azure Cosmos DB for PostgreSQL database, they are standalone Postgres servers. So we're going to talk about later on what that looks like. There's two different types of servers, and I will stress this over and over, they are standalone Postgres servers. That means you're writing Postgres queries, Postgres extensions. I even have a slide later on that talks about one of the other demos I did for another presentation with using PostGIS and what happens when you enable an extension on a single node and then you scale your cluster out. What does that look like? The latest PostgreSQL features and more, all sorts of things supported. Right now, Postgres version 15 is currently what's available for Azure Cosmos DB. It was 14 when we saw it launched in October. So they are keeping up with newer technologies as well. Some of the key use cases out there, these are ones that are more common. These are not the only cases that are out there. So if you're seeing things like multi-tenant applications or real-time dashboards or time series are really strong cases for working in Azure Cosmos DB for Postgres. No. With that said, let's take a look at how do you even create an Azure Cosmos DB for Postgres account? Because you know, at the end of this talk, you're going to want to go ahead and do this. You're going to want to play with this. But how do you get started? But before I do that, are there any questions in chat that I need to address? Okay. I see Sean's shaking his head no. So continue on. So how do we create it? So there are a couple options I'm going to show you. The first one is that you can try Azure Cosmos DB for free. Did you know that? Did you know that you can try Azure Cosmos DB for free, no credit card required? Just a Microsoft account or a GitHub account. You go to the URLs cosmos.azure.com/try, or you can scan the QR code on the slide. But that'll take you to this Try Azure Cosmos DB for free. On the Try Azure Cosmos DB for free screen, we have the ability to choose laser pointer, different APIs. Azure Cosmos DB for PostgreSQL happens to be one of the recommended APIs for mine. If you go to this site and you don't see it up front, there's this others section. It could be buried under there. But every time I've gone here, I've seen it here. I just have to call out others just in case. Now I have a full Azure account, but at the same time, I wanted to see what this trial did. So the next few screenshots that I'm sharing are from when I created my own using this Try Azure Cosmos DB for free. So when you go to do that, it's going to ask if it can have permission. Notice it says Try Cosmos DB for PG for Postgres. So it's going to ask for your consent. Once you give consent, then you're going to be in what's known as a sandbox trial. So the sandbox trial, think of it as just like sandboxes, for example, like if you're on Microsoft Learn and you need to test some things, it's very limited what you can do. But what it does is it has its own, it's not tied to your subscription per se, it's tied to your account. And if you don't see it in the Azure portal, it's under switch directory. But you'll see that it calls out how long you have. And if I were to pull this one out today on my browser, I think we're down to maybe 2 days left. So This is a fairly newer screenshot, so that you shouldn't see too much change. But things to note with this. So the location, I had no choice in the location of where it is. It's wherever they decide to put it for that subscription. Notice here, subscription, try Cosmos DB for PG. So it's something that's generated on their end. No replicas. We'll talk about coordinators and workers in a little bit, but this is the limitation in terms of resources. So you're looking at 1 vCore, 2 gigabytes of RAM, and 32 gigabytes of storage. This one, Postgres 15, Citus 11. Citus 11 is the newer version to be working with for that as well. You're going to see a message that says to get started with your free trial, you must change your password here. That change your password is your password for your server for your Postgres environment. That is not your Azure password. The context on there is not really caught well. So that's why I want to point that out too. When I first saw that, I'm like, why do I need to reset my password? Now, if you are like, you know what? No, I want to create one and I don't want to go through the trial. What does that look like? In the Azure portal, you can tell it to create a resource, choose Azure Cosmos DB, and then you'll see this screen here, which is which API suits you. And then Azure Cosmos DB for PostgreSQL is the bottom right-hand corner. It is the 6th one when it's in the 3x3 grid. And you'll tell it to create. When you tell it to create, there's some gotchas that I want to point out. First, you've got your subscription resource group, pretty standard there. You have this thing called a cluster name. We're going to get into there's a couple types of what they call nodes, and those nodes make up a cluster. And a single node is still considered part of a cluster. So the cluster name, think of it as like your Cosmos DB account name. So if you're familiar with the other APIs, Azure Cosmos DB accounts, that's what your cluster is for Postgres. Location can be wherever you need it to be. You have the ability to change your Postgres version. We'll come back to scale here in a minute. So the Postgres version, and then you set your administrator account's password and confirm the password. The username is hard-coded to Citus. That's what they do. So be aware of that. Now, I said we're going to come back to, there's a section here in the form that's called scale. And I always point that out after because we have to go in and we have to configure it. Again, this is context-wise, you're on your own Azure account, and this is not the free trial. The free trial, you're limited to what's known as one node. All right, so nodes, there's what they call the coordinator node and worker nodes. When I mentioned earlier that all of the servers are standalone servers, that means the coordinator node is a standalone Postgres server. The worker nodes are also standalone Postgres servers. It's all Postgres down the line under the covers. And that's one of the things I love about Azure Cosmos DB is that you can see that it is Postgres.
Sarah, I've got a quick question that came in.
Yeah.
And I love the fact that you pointed out that there's a free trial version of this. And I know with some of the other stuff, there's like, you're limited to like 400 RUs. But I don't know if that actually applies to Postgres or is that across all products of Cosmos? The limit of I mean, do they all use
400
RUs?
the free trials?
Yeah.
So going through this screen, I've not seen the free trial. The only way I've seen the free trial is through the cosmos.azure.com/try.
Do you know if all the products under Cosmos do they all use RUs?
I don't believe so. That I don't know off the top of my head. I know some are RUs. I don't know if they all are.
Okay, I know the NoSQL is, and that's where my experience is.
Mm-hmm.
But one of the questions came in regarding the free stuff is, do you know of any Learn modules that you step through, but you only use the free stuff, the free version of Postgres? So
the ones that I have a link to, there's a learning path in Microsoft Learn for Azure Cosmos DB for Postgres. Very familiar with those modules. The first one where it talks about modeling, you can get away with the free. The second one, I believe, is the one that gets into ingesting data and should be fine. The third, I believe, goes into the extensions and should be mostly okay. The part that won't work well is when we get into like scaling and read replicas. things of that nature, those you won't be able to do in the free resources one.
Okay. All right. Thank you.
Yep. Like I said, I have a link to that at the end, and I have QR codes for all these too. So if you're just like, you know what, I want to learn about this right now, feel free to scan it. Okay. All right. So the worker nodes, as I mentioned, there's you can start out as a single, or you can start out as multiple nodes. For the single node, the minimums that you're looking at right now are 2 vCores, 8 GB of RAM, and 128 GB of node storage. This is the bare minimum for a single node. However, if you need to consider scaling out to multiple nodes, then you want to consider more resources, more compute, and more storage. And I believe I think that's on my next slide. So I know it's called out in the Microsoft Learn modules as to how to do that. Specifically, remember seeing them put that in there. So for this one, notice when we go from 1 to 2 nodes, notice that the compute and the storage are different. So we're talking 4 vCores, 32 GB for compute, and 512 GB for storage. Those are for the worker nodes. And then the coordinator node has its own as well for minimum requirements of 4 vCores, 16 GB, and 512 GB. You can tune your workers and your coordinators to have different computes and storages. But if you want to go from this configuration of 1 to be able to scale out to 2 like this, you're going to want to go to a single node with 4 vCores, 16 GB, and 512 GB for your node storage. The reason why I pointed out here is because when you go to scale from single to multiple nodes, more often than not, there's a reboot required, a restart required, which will be downtime for your service. However, if you know these numbers ahead of time and can plan for it ahead of time, that restart won't happen. You can enable high availability when you're configuring this for your own Azure account. High availability is not available in the free trial. So just be aware of that. With high availability comes additional costs. High availability is mentioned in the Learn module. You can do it, but I know that the Learn module also says at the end to tear all your resources down because it gets expensive if you leave that out. All right. The other thing that I point out with creating a cluster is the firewall rules. There's still seems to be a bug. So I noticed this right when it came out, and then when I tried it again earlier today. So I've been tearing down these resources and rebuilding them left and right. But there's still this issue where when you go to create the resource, the network tool or settings don't always, like, they propagate to the confirm page, but then on provisioning, they're lost. And so then you have to go back and reset the networking. It's a known bug. We've talked with the Microsoft folks about that. So I always point out in my presentation, just create it without the firewall rules, and then you'll add the rules when you need them. So tell create cluster. Once it does the create cluster, then you have to come back once it's created and go into networking and tell it you want to allow public access for the Azure services and resources. If you have Azure resources that need to access it, if you're working in Azure Cloud Shell and Npgsql, which is their command line, you want to make sure that that is enabled here as well. This allow public access. There are more options like other Azure resources. You can allow your IP address. You can also allow wide open 0000 to 255, 255, 255, 255. I saw Michael's face on that. I don't like doing that. I don't like having to do that at all. So I will avoid that at all costs if I can. But I'm going to also warn you, if you're familiar with Azure Cosmos DB and their accounts and their structure here, if you're curious about the quick start, notice it says preview. Rest assured it is preview, but if you're trying to use, I think it's their PSQL shell and then some Cloud Shell stuff, they will tell you to check the 0000 to 255. And I cringe every time I see that. I'm like, Do we really need to do that? When usually allowing access to the Azure services within this cluster is enough. All right, so those are doing the provisioning of the account. So again, there's the free try Cosmos, no credit cards, just a Microsoft account or a GitHub account. And then there's, okay, now let's actually provision it through a paid account. So we've got the account. Next up is going to look at the code. Now, how many of you are using Entity Framework currently? See some hands? So I will be showing a lot of Entity Framework, but how many of you are using ADO.NET? I suspect there's probably some ADO.NET users as well. Rest assured, I've got demos for both. Now the ADO.NET one is a console app, so it's not anything too fancy, but I wanted to make sure I had that represented as well. This is not a VB6 demo. Oh man, I haven't installed the VB6 tools on here yet. And Mongo's a different API altogether. And Redis has Azure Cache for Redis. That's a different product altogether. All right. ADO from PowerShell, it's not my fault. Sorry, Randy, I don't have any PowerShell in my demo today. I'm not going to hold that against you that you're doing ADO from PowerShell. You work with the tools you're given. But we're going to talk about the EF core. So I'm using Entity Framework Core, clean architecture. The demos I'm showing tonight are .NET 7, just so you're aware of what that is. Under the covers. I like to show no tricks up my sleeve, but I also like to keep my sleeves down because it's cold in my office tonight. So
So
I see the
Andre's got a
question.
fantastic question about the
Yeah.
CAP theorem. Yeah, every database, and I preach this, and it's a big thanks to Michael Perry, because him and I have had major discussions about this. And anytime you deal with a serious, as in production, but an application that you are very serious about keeping it alive, you need to cross that bridge as to multiple instances, even including multiple instances of ways to store your data. So what happens when there's a network partition where you got copies of one data to another copy of another data in such way, what you're pointing out, Sarah, with the coordination nodes and the other nodes that you have? If there's a network partition, what happens? And I'm gonna let you give the answer, but I'd be I want to assume, and correct me where I'm wrong, but I want to assume that when you're hosting nodes inside Azure, there are multiple redundant network systems, because it's not just between inside a data center, but cross data centers, and even to cross availability zones, depending on which region you're in.
Yeah.
Thoughts?
I have not looked at that part in depth, so that's a one I would have to look into and get back with you on. And when you say the network partitions, you talking like net splits, like what we had way back when?
Yeah, it's like basically that a TCP/IP decides to in all of its chattiness, but can't connect. I mean, like an actual physical router has stopped working inside of a data center, so another system has to come into play. Or you know, on the global scales, you have an Azure region that's replicating to another Azure region, two different states, right? And there's a network break in between, fiber cut, things like that, depending on various levels of severity. To give more food for thought for Andre and others is, and this goes back to the conversations that Michael Perry and I have had, your system is not going to be what determines if it is favoring consistency or favoring availability, but instead it's going to be the business processes inside that application or that system, because you can store data in different databases just because of the data needs, not just because it's one app. And same goes with what's the business processes that you are concerned with, and that's going to help dictate your need for favoring consistency or availability.
Mhm.
And
That
there's
make-
one other thing I can add there. Sarah, you already mentioned that each node is a full Postgres
Yes.
database.
Yes.
So that tells me that in the case of a network partition, you still have that full Postgres database, and it's still acting as a Postgres database. And so
Yes.
that means it would favor availability in that situation. And those two replicas would become inconsistent during that network partition. But then when the network partition is restored, then there's got to be some kind of log shipping that's happening to bring them back in sync.
You can connect directly to the worker nodes and to the coordinator. You can connect to those nodes individually. They have names that access them. But yeah, in terms of partition tolerance and all that, I'm writing this down. So I have a notebook and pen that I always keep notes on. And I'm going to look that up and see if I can get you guys better answers on that, because that one I don't know, but I haven't really looked into that. All right. Make sure there aren't any other questions. Okay. All right, so clean architecture with EF core. Before I flip over to the code, so we're going to go through the steps of what we need to look at. This is a simple to-do list. I say simple. There's repositories and other patterns being used, but the actual functionality-wise, it just has a to-do list with a bunch of to-do things, and it's going to work better if we look at the API as well. So I'll show you what that looks like. But what's going to happen is you install this template. So Ardalis, if you're not familiar with him, also known as Steve Smith, he has this clean architecture repository on GitHub. But you can access the template itself using this .NET new command -I and then ardalis.cleanarchitecture.template. This allows you then to be able to create new projects using the template. You don't have to worry about scaffolding it over and over and over. Then you can create a new project, .NET new clean architecture. You can do the .o, your project name. You can do it right into your current folder. Just don't use dashes. There's a bug with that in the repo. It has something to do with the way that the templating works. So it's outside of his repo where the problem actually initiated, but just so you're aware that it does apply to this repo. Then we're going to add our Postgres dependencies, and I'll call all these out in the demo, but I want to point out these steps so you can see that it's not just a straightforward, okay, let's go to Postgres. There's configuration we have to go through. We'll get into using Entity Framework Core's Postgres. There is a package for Entity Framework 6, but I'm not going to do a demo of it. I just want you to be aware that if you are in an EF6 world, there is a Postgres package for that. We'll update the app settings JSON. The example that I have here for this connection string where it says C dot in your account name, postgres.database.azure.com, that means we're going to Azure Cosmos DB for PostgreSQL. If you see in my demo, you might also see localhost because I will also run Postgres in a Docker container. So you can see all I have to do is change a connection string between talking to Azure or talking to localhost. The rest of the code stays the same. Then we're going to update our setup, set the DB context to use so Npgsql, that's the .NET driver for Postgres. So we'll tell the DB context to use that. Then we will update the connection string in program to actually use the connection string we want to use. Then we'll run it. So let's do that. I'm going to bring over my Visual Studio. All right. So I have Visual Studio here. And we said that the first step we wanted to do is we did the .NET install the template, and we do a .NET new to create the clean architecture. So clean architecture, I wish I could zoom that, but it's not going to zoom it. There we go. Okay, so clean architecture, we have different things going on. We have core, that's where your models are. Again, nothing up there with the sleeves. So you can see there's like a contributor and so on. We have infrastructure, specifically want to call out data. So your app.db context is here. Pretty standard to-do items, projects and contributors are going to be the entities that we're going to look at in here. You'll see all the save changes, things like that. Nothing we actually have to worry about and change, but the thing we have to change here in infrastructure is going to be our startup setup. Now, I'm going to point out use Npgsql as is. And then I'll show you the gotchas as to why this is a problem, and we'll take it from there. So we had to change this from the demo. When you run the template, uses SQLite. So instead of using SQLite, we're going to just tell it Postgres. The rest of the like queries it runs and things like that, I didn't have to change anything for that. There's email senders stuff. For this demo, we're not getting into any of that. We're just showing things. So yes, Andre, I see the question, is a sample available on GitHub? It is. I did show a link. I will post it in the chat, or Sean, if you want to grab it. It's github.com/ardalis / I think it's ardalis.cleanarchitecture. Shared kernel, it exists, but we didn't have to go in there and change anything. Okay, so we've got those. I'm just looking at the list that's right behind me to make sure we have all those. Okay, then we have the application JSON. So app settings JSON is in web. And I'm not worried about this because I'm going to destroy the resource afterwards. All right, so in my app settings, I have my default connection. I have a Docker Postgres, and then I have a Cosmos Postgres. These are just my connection strings. Now, when you create an Azure Cosmos DB for Postgres resource under connections, the connection string I'm using here is the ADO.NET connection string. Something to note with those connection strings is that you have to enter in your password. It has just curly braces your password here. So be aware that you'll want to go back and change that. But I have two different ones, my Docker one being my local host, Cosmos being the cloud, so that you can see that it's easy to change in between them. Okay, so we got that in place. And the next one is the startup setup, which I showed you, and then program.cs, which is right here. And on line 26. Can you tell I've been looking at the code a bit much when I can tell you exactly the line number?
I was admiring the size of your monitor when you had to look behind you to get something else.
So
teasing.
I am demoing on a 15-inch laptop screen, and my whiteboard happens to be behind me.
Nice.
Yeah. All right. So the connection string is the only thing I need to change here to help it on startup to go, okay, we're going to call out to Cosmos. Now, I'm going to go ahead and tell it to run the web. And I don't know if it's going to pop up here, if I'm going to have to drag it over. Yay. Just to show again, no tricks up your sleeve. So if there's any data in the database, it's not going to call the seed data. Otherwise, we're going to populate the seed data. Yes, Douglas. Sometimes my speaker notes are in front of me, but when I'm writing code, and especially the past few days on the whiteboard, it happens. All right, so we're populating the test data. Go ahead and run that. Did it open? It opened. There it is. Okay, so let me pull that over. All right, so this is the application as it's running. As my program.cs showed, we're calling out to Cosmos. It's an Azure Cosmos DB cluster. So let me pull that over. There we go. All right. So this is what I've got so far for my Azure Cosmos DB cluster. You'll notice I have a coordinator node and my worker nodes are dashed out. That means I am in a single node setup. 4 cores, 16 gigabytes, 512 gigabytes of storage is what I've got for that. So again, no tricks up my sleeve. I don't have read replicas turned on. I don't have high availability turned on. I just went with this straight, give me a single node to work with. I can do the quick start just so you can see here. This is where I was telling you about the change network settings. And if I tell it change network settings and I come here and it's going to say, hey, you want to do this, and hey, you want to do this other, allow zeros. I don't like having to do that, but fine. All right. The reason why I want to pull this up here is so you can see what I'm looking at database wise. Okay, so I am at the Citus prompt. This is using PSQL, which is their command line interface. And I just want to do a /g to describe their database. So you can see that there's a contributors table, a projects table, and a to-do items table. Now, you know what? I did not show you the no tricks up my sleeve. So I am going to drop table to-do items first. I'm doing this specifically. This is going to fail, and I want you to see why. Notice it says to-do items does not exist. But to-do items is right here. But table to-do items lowercase does not exist. Postgres will lowercase their queries, which is maddening because, yeah, like Sean says, oof. So then how do I do this? Well, then I actually have to put the name in quotes. So drop table to-do items. And so now if I describe, that stuff is gone. That's kind of gross. So that means, okay, if I do select star from contributors, I know I'm going to have to put contributors in quotes. Notice ID and name are capitalized. So if I only wanted just those names, it'd have to be select name in quotes from contributors. That's pretty awful. To make things even more gross. All right, so I'm going to pull that out. We will come back to the web part, which is running EF core. Let's run our console application. So I have a console application. Now the console application is not part of the template, and I will end up putting this in GitHub, and then Sean, I will get you the URL for the GitHub repo for the console app. With the console app, and we'll resize that guy. There we go. So I've got here some thing. We've got the Npgsql that is going to be the dependency from NuGet. And then the only other thing I have to point out is I've got, for ease of demoing, I have my connection string in an environment variable, but you can put your connection string however you have it, wherever you normally get your connection strings from. But then I'm going to create my data source, and then we pass my data source to my different methods to do their things. This is ADO.NET. You know it because we've got our friends execute reader async, execute non-query async, and then execute scalar async. So when I did the app for this, I made sure to show those three just so you could see how they are. And I chose to leave them in the form of the slash quotes so you can see how gross that looks. Do you really want slash quotes in your queries? I mean, to me, having worked with data for most of my career, it just makes me itchy and think about like SQL injection and but I do use parameterized queries so you can see, and I specifically use named parameters, but they also have positional parameters. The Npgsql documentation is great at explaining the different cases for there. So what I have for the command line, so once I create my data source, I'm doing the standard ADO.NET patterns of creating commands and reading and using readers, things like that. But if I want to pass in a parameter, what I do is I create the command, and then in the query itself, I'm just using @ for the variable. And then this is a name parameter. So contrib name is the variable name in there. And again, this is an insert, so that's why it's a non-query. And for scalar, I love using aggregates, so counts. And if we go ahead and run it, before I do that, I just want to make sure my environment variable is my Cosmos connection string. So we're talking to the same database as the website. And then I'm going to right click on this and tell this to set as startup project and run it. And then I will bring my terminal here. I'm going to tell continue. And so you can see that it just writes out. So ADO.NET, this is the demo I have for ADO.NET. It follows all the other ways we work with it. So if you're dealing with any patterns outside of that, as long as you see how your ADO.NET calls are being made, it's, again, fairly standard, your reader, your non-query, and your scalar. All right, so that's ADO.NET. Going back to Entity Framework land. So we saw with Entity Framework, capital letters. Let's talk about them capital letters. Thankfully with Entity Framework, we don't have to do anything. Entity Framework is doing its thing under the covers. It's handling all those quotes for us. So I can go back to running the website and showing it in action. Now this is a project that's newer for me, so that's why the UI doesn't have my touch of Dodger blue and lemon chiffon or other colors that have no business together. But the guys who've been working on it are more on the service layer, so the API is a little bit prettier. So we'll show, just so you can see, to-do items does not exist. So because I deleted it. Do I still have that browser window open? I do. Let's go delete the others as well. So I need to describe the table or describe the database again. So /d and drop table projects and drop table contributors. Make them go away. We'll let EF recreate it all. Okay, gone. Just to make sure they're gone. Gone. Citus tables, that's for distribution. And then the rest are Postgres under the covers. Okay. So now let's try this again. Run. There we go. So now we're populating. Go ahead and run it. Bring this back. Okay. All right, so we showed the casing problem, and we showed one of the ways to get around it is the quotes. We'll go into our API. Let's say we want to get all of our contributors. Go ahead and try it out and execute. And so you can see these are our contributors. Notice it's coming back in lowercase, but in the database, that is most definitely not lowercase. Let's say we want to add a contributor. So I need the post, which is up here. Post. Try it out. Name. Put Sean in there. Notice I get a 200. Sean is ID 3. We'll put Michael in there. Perry. And execute. So Michael is 4. So you can see that it all works fine. This is all Entity Framework under the covers. It's all EF core. If we wanted to see like projects, so you can see what that looks like. Get a project, try it out. Lots of swagger. Execute. It's all the projects. There's only one test project, so. But this is what you get to start out of the box. Postgres, all I had to do was change a bunch of configuration to get it to work. I didn't need to change any of the queries. The queries are all handled fine with the extensions. But that still bugs me with those quotes. I don't like quotes like that. I'm a developer. I have opinions. You know how they say developers are opinionated? Very much the same. So what do we do? How do we handle that? Well, if you're in EF Core, do you know about EF Core's naming conventions? That package. Let me show you that. So I'm going to go back to my PSQL and get rid of those tables. So come back PSQL. Password. And just so you can see that those got recreated. Capital letters. So find drop table to do items. Drop table projects, and then drop table contributors. All go away. Okay. So those are gone again. So you can see that they're gone. So what I'm going to do is I'm going to the, where is that, infrastructure, startup setup. We can add something here for snake casing. But in order to do that, we need to add a package dependency. I'm going to go under my dependencies and make sure I don't have it there. I do not. I removed it so I could show you all how I do it. So I want to manage the dependencies, manage dget packages for infrastructure. I want to do a search for EF Core naming conventions. It says if I was in here recently that it knows, hey, you want this? Yes, yes, I do. Hit install. EF Core naming conventions allows us to have better control over how things are named in the database side of it all. So I'm going to tell it okay. Close it. And I'm going to come into, I am in startup setup on our DB, where we're doing the DB context, they use Npgsql. We're going to chain off of that. Use snake case naming convention. That is a method, so I need to do that. All right. So now then if I run the website again, it'll seed our data. There we go. So you can see that we're hitting the point where it will populate the data. This looks good so far. We're getting values. Now let's come over here. I'm going to do /describe /d. And now look at, there's contributors in lowercase and projects and to-do items. In snake case. Snake case is the demo I show, but the EF Core naming conventions has other conventions in there as well. So I would recommend giving that a check. And now you can write queries again with lowercase and it will work nicely. So I could do my select name from contributors. Now, let me pull the API back and let's add the people and then run that same query just so you can see that I am connected and this isn't some kind of mock. Because I know that sometimes people are like, wait a minute, kebab case is pretty cool. All right, so I want to post some contributors again. Try it out. Sean. Michael. Do you really think I'd forget my heckler? Doug. We'll put Doug in there too. All right, so then if I come over here.
I've really been very quiet.
You have. You have. That's why I was like, wait a minute, just so you know, I haven't forgotten about you, even if you are being quiet. And so now if I do a select name from contributors, you all appear there. And this is still Azure. You can see Portal Azure. So. Now that said, could I run this in my local Postgres? Sure, could do. I could change all my connection strings from the Cosmos one to my Docker and run it that way. There was one other tool I wanted to show you. So I showed you PSQL in the browser, but if you happen to have Postgres tools, if you happen to deal with Postgres often, pgadmin works fine for running these queries against the database as well. So this is my pgadmin, or for the SQL folks, think of it as this is the SSMS equivalent, SQL Server Management Studio equivalent for SQL Server. This is that equivalent for Postgres. pgadmin, you can see all sorts of things going on. I have connections to my localhost Docker and to Azure Cosmos DB. I can navigate them to Citus. I can go through the public schemas, which is where my tables live. I can go under tables. I'm going to refresh, and notice now they showed my lowercase ones. But I was in here earlier doing my drop tables here. I was debating demoing with the PSQL shell in the browser, and I'm like, well, if that doesn't work, then I'll fall back to pgadmin. So you can do that. So I could do here, select star from to do items. And that's not what it's called though. It's now to do items. And so then I can press F5 to run that. It tells me the outcome. Now I have the ability to change the font on my queries just fine. I haven't found the way to change the font size in the results. Other than I think there's like a zoom option under, where did I see that, file runtime zoom in? But yeah, the tooling, it's not SQL Server, but it works enough to get the job done. But you can see here, these are the to-do items, querying from the server. Just to show you that I'm still querying from the server, let's look at our contributors. The folks that we added through the API should appear, and they do. All right, so we took a look at that. I'll pull that out. I'll pull that out. All right. So we looked at the console app for ADO.NET. Saw the code for that. We did the demo of pgadmin and what's going on with the tables. We talked about the needing the double quotes, or in our case, use EF Core's naming conventions to make our life a lot easier. So we added snake case to entity framework using EF Core naming conventions. Some other things I want to point out about Azure Cosmos DB for Postgres. So it's main thing is distributing data. So yes, what we're doing for tonight's demo is just a single node, but I could scale it out. And then distributing the data horizontally. So I suppose with our to-do app, it would be a stretch, but let's say that Sean and Michael and Douglas and I all want to keep our to-dos in here. And we only care about looking at our own to-dos. We don't need to look at each other's to-dos, and all of our queries are focusing on that. Then we can distribute the data so that like Michael's, we would distribute it on what we would call like the user ID. And then all of Michael's stuff would be stored together. All of Sean's would be stored together. All of Douglas's would be stored together. All of mine would be stored together by that ID field. So you have to choose an ID on how to group your shards. So shards is the term that you'll hear. Think of them as their partial tables. So if we have all these, for example, the contributors, not the contributors, but like if the to-do items belong to the contributors, they have a contributor ID on that to-do item. The contributor entry plus the to-do items with that contributor ID would all be stored together in the same shard, or not in the same shard, the same node, but the shards for each of those. So the partial table for contributor, partial table for to-do would all live on the same node. So again, that's to optimize for running these queries in parallel and working like that. That is covered well in the Learn modules for this. So that's why, for the sake of time, I'm not getting in depth with that. Just be aware that you can do this. The worker nodes and coordinator nodes are all Postgres under the covers. That's why when I created this image, I made sure to show those are individual Postgres servers all working together. The coordinator node knows where the data lives. It knows which shards based on hashes. So it stores hashes and it knows that shards with this hash live on this node, this other node, this other node. One moment, I need to. I apologize if my voice is cutting out. My sinuses this year are taking it out, and I'm just like, no. So the coordinator node knows where the shards live. Sometimes those shards live on the coordinator node, sometimes they don't. If you start in a multi-node setup, then the shards never live on the coordinator node, at least for now. But then if you start in a single node setup and then scale out to multiple nodes, then shards can live on the coordinator node. And that's just because in a single node, they live on the coordinator node. So the coordinator node knows where they are. There's a thing called a shard rebalancer, which allows you to balance the data appropriately. You don't have to try to do any calculations or stuff like that. You just have to go into the shard rebalancer in the portal. It'll give you a query to run, and then you run it against there. There are 3 different types of tables when it comes to distributing your data, and it depends on where they live and the relationships. Again, for the sake of time, I'm going to defer back to the Learn modules that are linked at the end. Just know that you can have data living on the coordinator node. That's usually like user information authentication, something that doesn't need to be used in a join query with everything else. Then there's reference tables, which are smaller tables of data that gets shared, that gets replicated across the other nodes. And then distributed is taking that large, breaking it into smaller shards, and then the shards are then distributed across multiple nodes. So reference, think of it as copies, distributed are the shards. Foreign keys, primary keys, relationships will change based on the distribution. So this is where we get into what works in the distributed environment. If you're staying on 2 local tables, that's within the coordinator node, that's fine. Relationships are good. 2 reference tables, they live on the same node, that's fine too. Going from reference tables to the local tables works okay. If you're going to 2, so co-located means that they have the same ID and that they are living, like, so using the contributor and to-do items for examples, the contributor, if they were assigned the to-do items, contributor has an ID field, to-do items would have a contributor ID field. The both having the same contributor ID field and same values would be co-located. They'd live together. That's how that stores the data together. Again, we have more on that covered in that Learn module because it gets into, there's a couple gotchas with that. And then from a distributed table to a reference table, the relationships work, but it matters in the order that you move things. When you're working in a distributed environment for Postgres, be it for Azure Cosmos DB for Postgres or using Citus on your own, you'll run into issues with correlated subqueries, recursive CTEs, table samples, select for update, and grouping sets. To add worker nodes, so to go from our single node to multiple nodes, that is in the portal. So what you're dealing at that point is you're going to scale. And then when you change from 1 node to multiple nodes, so 2 or higher, then this coordinator will appear. Single node, this section doesn't appear. More than 1 node, then it does appear. Believe the portal is still up to 20 nodes, and then after that, you have to reach out to Microsoft, and then they talk with you on a case-by-case basis if you need more. So this is not available in that free trial. I can't call that out enough. This is what it looks like when you have a scaling situation. So you'll have a coordinator node, you'll have your worker nodes. They have their names. We'll see -C, W0 and W1, but they also have FQDNs, fully qualified domain names as well. So they are accessible. They have availability zones. They have high availability that can be turned on. This particular screenshot I captured while it was doing the provisioning, so you could see what it looks like as that scaling was happening. Now what happens when you have data on your single node and you're ready to go to multi-node? Then you create multiple nodes, but even though the multiple nodes are there, the data doesn't move. The data doesn't move until you tell it to, which means you come to the shard rebalancer. Timing matters a lot with this. So when I took these screenshots, I had already kicked off the create the multiple nodes, and it said, hey, rebalancing is not recommended at this time. So I was still at the spot where it was in provisioning. And so it was just like, oh no, I just have a coordinator. I don't know really about the worker nodes. You're fine. Like, really? I know I'm rescaling it. So it said not recommended. Fine. And notice in my screenshots, the weirdness is there's 0 gigabytes, 0 gigabytes. So that's your giveaway that the node isn't ready yet. Okay, now there's 2. And finally, okay, now there's 2, but rebalancing is still not recommended. Hold up, I still haven't distributed my data. Well, there we go. So it worked really well for me when I was doing screenshots for the talk of like, okay, my impatience will show you how that number changes over time. And then from there, the rebalancer. So there's this view rebalancer execution plans. There's 2 different ways you can go. You can go by shard size or shards or disk size. And so it'll tell you which ones do. I'm going to tell you if your data is in a spot where it'll tell you one thing, you run it, you might still have to rebalance the second time with the other strategy. So always run the rebalancer and read what it tells you. But don't be surprised if you have to run a second rebalancing. It all depends on the shape of your data. It depends on how much data you have distributed and how you have it distributed, like what column you chose for the distribution. If you need to trigger the rebalancer, there's also rebalance table shards. When it's rebalancing, you can see how things are going from one thing to another. So that gives you a little bit insight. Okay, yeah, this stuff is actually moving. Again, this was a case where the rebalancing was still recommended, even though it told me to use a different plan. This is the by disk size is where we ended up using it. Once you rebalance, it eventually will come back to rebalancing is not recommended at this time. So hopefully you don't end up in the loop where your data is not really in a good balance state and you get stuck in rebalancer loops. In which case, at that point, you choose one and hope that you get enough data to be able to deal with that more. No, the worker node. So there's no worker nodes do not have to be an odd number. So it goes from 2 to 3 to 4 and so on. Actually, let me pull up so you can see that. That's this one here. Full screen it. Scale. So when I want to scale it, notice 2 all the way to 20. It's in single nodes. Yeah, the concept of quorum doesn't apply in this case. Not with, yeah, it does not have to be odd numbers. All right. And I'm not going to scale that cluster because we aren't going to demo that tonight. But just so you know that capability is there. Some Postgres extensions that we found helpful when playing around with this is PostGIS when you're dealing with geographic data, pgcron to schedule your Postgres jobs, pgdump to backups. And then if you're dealing with Azure Blob Storage, PG Azure Storage is something to look into as well. There are 2 queries for querying extensions to see what's available and what's pre-installed. Those are PG available extensions and PG extension. Now I have a quick story on extensions. So I did a talk about Azure Cosmos DB for Postgres a few weeks back and talked about having PostGIS on my single node. When I went to scale and I ran my query with PostGIS, kaboom. When you scale, it does not install the extensions. So you're going to have to drop the extension and then create the extension. Now in the Postgres realm, you'll have create extension and drop extension as like SQL keywords. but you don't have that access in Azure Cosmos DB for PostgreSQL. So that's another one of those gotchas. That's when you use these helpers like drop underscore extension and create underscore extension. So those are the equivalents to the create extension and drop extension SQL commands in Postgres. That goes in back to Azure Cosmos DB for PostgreSQL being a hosted managed environment. You don't have access to some of those SQL commands, but they do have some helpers out there for cases like this. So that's how this works. This was the error message that I saw. So it couldn't find the geometry type. And the thing that tipped me off was this private-w0. Private-w is a worker node. I'm like, the worker node doesn't have it. And for me, I found the create extension very easy in the documents. Drop extension, I didn't find it. So I did the programmer logic of, okay, create extension seems to be like the sequel to, let's see if this works for drop. And sure enough, it did. So if you run into scaling and you're like, why doesn't my extension work? Well, it probably needs to be dropped and then recreated. Now, when you recreate it, it'll apply to all worker nodes. So that makes it easier. What other tools would you use in this kind of environment? So pSQL, pgbench, pgadmin. For our demos for .NET, you use Npgsql, and you have ADO.NET and EF Core support. Also EF6, but I don't show that. The EF Core .PostgreSQL, I say it's optional because if you aren't working with EF Core, you don't need EF Core. But then if you are dealing with EF Core, I highly recommend EF Core naming conventions so you don't have to have funky quotes if you end up having somebody else querying it. All right, some resources. So as I mentioned, there is a Microsoft Learn training path for Azure Cosmos DB for PostgreSQL. There are 4 modules in that training path: data modeling, ingesting extensions, and then managing performance and availability. The managing performance and availability will cover your scaling, but it also gets into the high availability and read replicas and how those work as well. So we've got a QR code for that. That's a search on Microsoft Learn for Azure Cosmos DB for PostgreSQL training path will get you exactly where you need to go. I might have done that search often because I talk about it often. The other thing I want to point out, April 18th to the 19th, the virtual conference, it's called CitusCon, an event for Postgres 2023. If you remember one of the earlier slides in the beginning, I mentioned Claire and the pronunciation of Postgres. This is the conference she was talking about, CitusCon, an event for Postgres. Free talks. It is going to have 37 talks, 2 live streams, all sorts of details coming out there. So it's community folks, it is Postgres folks, it is Azure Cosmos DB for Postgres folks, Azure Database for Postgres, flexible server customers, I mentioned, all sorts of Postgres and Azure and Cosmos and love. The talks from last year are also available. I added a bit.ly QR code for that as well. That's AKSMS CitusCon Playlist 2022. So if you want to learn more about Citus, I would highly recommend these videos. I have watched probably most, if not all of them, some of them twice because they are just that informative and that well presented. And if you have any questions for me, if you're on Twitter, you can find me as Sadukie. On LinkedIn, I'm /in/Sadukie. I'm probably Sadukie just about everywhere. At least for that. There's a QR code. Feel free to connect with me on LinkedIn if you have any questions. I'll gladly send more links your way as you need them. Other than that, thank you all so much for having me. And
Yeah, thank you, Sarah.
I am planning on hanging around for a bit as well.
Awesome, awesome. So I wanted to ask regarding Postgres on Cosmos.
Yes.
Does that mean that this Postgres also gets the benefit of the 5 different consistency levels? I'm more used to the NoSQL, so you get the eventual, you get the strong, and you get the 3 in between. So I didn't know if that also played into here as well.
I don't know. I need to look that one up to see. I know the one for NoSQL because that has my most favorite Microsoft document of all. because I don't know if you've seen the consistency levels document. If you haven't seen it for Azure Cosmos DB for NoSQL, their consistency levels animation, it's an animated GIF. And so you can see the notes in sync to the various consistency levels. I think it just demonstrates it so very well. That's why I'm like, it's my absolute favorite document.
Yeah. I love that too. I love that too. When it shows them that they can be in order, but eventually it could be out of order and things like that. And
I'm gonna look that up.
And along with that as well as I'm going to check on because I want to assume that because one of the great things about Cosmos is that you can do geo replication. It doesn't just replicate to the paired region of Azure, but you can pick your other regions and multiple regions that you can replicate to. I don't know if that's available with the Postgres on Cosmos.
Yeah, so let me look into those.
Okay. All right. Does anybody else have any other questions?
Yeah, I've got one. I always like to think about if I were writing this, how would I do it? So yeah, if I were writing Cosmos Postgres, how would I do that? And so I'm thinking about the sequences. So in Postgres, for those who have only used Microsoft SQL Server, you're used to auto-incrementing IDs, and it's just when you insert it, you get an ID. In Postgres, until actually pretty recently, you had a separate object, an index, a sequence, and you would have to interact with the sequence in order to get an ID, and then you could insert. They've actually made it part of the insert now that it talks to the sequence, but sequences are still there. And in fact, when you did your drop table, there was the sequence right next to the table that got dropped right along with it.
Yeah.
So I'm kind of curious about sequences when you are talking about a distributed cluster of databases. The sequences still have to give you unique IDs across the whole cluster. So do you happen to know kind of how that, what limitations are around that?
I don't, but I do know when looking at the learn module, because that was looking at that. So when I first came into this Postgres side of things, I was coming with the SQL Server and so ints for IDs and stuff like that. And they're like, use Big Serial. And I was like, hold up, Big Serial is a thing. And when I learned about it, I was like, where has this been all of my life? Big Serial is what they use for Azure Cosmos DB for PostgreSQL. That's what they recommend. It's meant to work well with the distribution, but the hows, I haven't looked at that.
Okay.
It's on my list of if I had 96-hour days and could just focus on it all the time, I want to know. There's a lot that I want to know under the covers, like how is it doing this? And especially since Citus is open source, I'm like, oh, can I look at it? And I'm like, I could, but that's a rabbit hole that I would be having a hard time coming back out of. So I know when it comes to the ID field, like that Big Serial is what they advise. Now, what does that look like on the .NET side? I haven't gotten that far yet. I would love to play with that more, to go, okay, how does it do this? Because that was one of the coolest things I found when I was playing with Postgres and going from SQL to Postgres. I'm like, oh, Big Serial. And then they're like, yeah, and it works in Citus. I'm like, yes. Because auto incrementing otherwise, and then you having to keep track of that logic, it would not be fun.
Cool, thanks.
Sure.
All right. Any other questions? All right, we will go ahead and stop the recording. And before I do, Sarah, thank you again. It was great to have you here. I really appreciate it. And I certainly learned a lot more about Postgres, but also some of my misunderstandings and about that sitting on top of Cosmos. And again, coming from a NoSQL experience only, that helps open up a lot of options on that. So, and I could definitely see its place with having relational, but also distributed. And so a lot of applications these days, certainly hosted in the cloud, need to make use of that. So all right, go ahead and stop.